y equals 2x squared log n 3x. We know that the log is only defined for positive x, so we can exclude the negative and the value of 0. So let's just sketch in these constituent parts of the product. The 2x curve, let's do that one. So the line 2x then, let's just draw that, like so. And then we'll draw the log. It comes up from here, cuts through the origin, and then turns and shoots off down in this direction. This value here, this needs to be 1, so x is a third, isn't it? So that's a third. And then we get 1 here, and log of 1 is 0. And that's actually a value on the curve, isn't it? Because 0 times anything is still 0. So that would be a value point on our curve. Now, let's have a look here then. So what happens to the curve? Well, first of all, below a third, you've got positive times negative, so it's negative. When you have a look at small x, this will be really, really small. Say 0.1, say, and this would be log of 0.3, which is 0.3, yeah, which isn't that negative. So if we look at that on the calculator, I'll just illustrate that. If I type in this, so it's 2 times x squared, and I'll put 0.1 in, squared, and then we'll do log ln of 3 times 0.1. So 3 times 0.1, isn't it? There's our x value, equals minus 0.02, really, really small negative. And if we went back and we put 0.01 in, so I'm just illustrating here what it tends towards as x gets smaller and smaller and smaller. So let's work out 0.01, really, really small number but negative. So it's going to tend up to 0 here, and then it's got to come round and turn up here. So the curve is going to actually look like that, isn't it, up to there. We think there's a minimum here, so we need to differentiate this. But let's have a little look here then. Now it merges into the positive because these two products make a positive. This just continues to increase, and this increases as we go along. So basically the curve should just continue to increase like so. So there's what we think the curve looks like then. Let's get this turning point just out of interest. So here, y dashed is equal to, it's a product, so it's u, times dv dx, and log 3x is log of something. It differentiates to 1 over the something, multiplied by the something differentiated, which is 3, plus v, which is the ln 3x, isn't it? That's v, times du dx, which is 4x. So let's just simplify that then. Equals, now one of the x's will cancel, the 3 will cancel, we'll just get 2x here, plus 4x ln 3x, and that's equal to then, let's take the 2x outside the bracket, and it's 1 plus 2 ln 3x, let that equal 0. Now we know x is 0 is excluded because log is undefined there, so the only turning point can come from this. So when ln 3x, this equals 0, then move the 1 over, minus 1, and then divide by the 2, move the 2 from times to divide, and so 3x is equal to, undo the log, there's an e here, log base e hits the half in the air, and then divide by 3. So it's e to the minus a half, which is a small number, divided by 3, which is smaller still. So the turning point will be a very small number here, and we've got our turning point. So it comes from there, it turns, and then starts to go back up, and then we think it increases. So let's verify that then on our plotter. So I'll type in 2x squared log 3x, 2x squared times ln bracket 3x, and we'll do it from 0, say, to 4. Let's just try that. We might need to change that in a moment. Yeah, it's hard to see, so let's just do it up to, let's do it to 1. See if we can see the shape there. We're starting to see it, aren't we? Emerge. Now we'll go to, say, 0.6. Let's have a look at that. 0.6. Get a good look at the curve then to see if we've got its characteristics correctly represented. Yeah, see it there? So we've got our minimum, and then it swings around through a third up to being increasingly positive.